Electronic configuration of elements based on subshells. Students, you've already learned about the electronic configuration of elements in your previous class. Can you tell me what the electronic configuration of an element is? Yes, the distribution of electrons of an element in its shell or orbits is called the electronic configuration of the element. In the previous class, you must have learnt the electronic configuration of elements based on shells. Let us revise the configuration in short. In electronic configuration of elements based on shells, only 2 electrons can be kept in the first shell, that is case shell. 8 electrons can be kept in the second shell, that is L shell. 18 electrons can be kept in the third shell, that is M shell, and so on. Here you will learn about the electronic configuration of elements based on subshells. The electronic configuration of elements based on subshells is an elaborated form. Here, electrons are distributed in the subshells of an element. There are mainly 4 types of subshells: S, P, D, and F. The subshells S, P, D, and F can fill 2, 6, 10, and 14 electrons respectively. The first shell has only one subshell, S, and the number of subshells increases with the increase in the number of shells. That is, the second shell has 2 subshells, S and P. The third shell has 3 subshells, S, P, and D. The fourth and other higher shells have 4 subshells, S, P, D, and F. Students, you have already learnt about the electronic configuration of elements based on subshells. Let us take a look at the electronic configuration of some important elements. Electrons of an element are distributed in different subshells. In the process, we can see that last electron is distributed in certain subshells. Based on that, the elements are categorized as S-block elements, P-block elements, D-block elements, and F-block elements. Here you will learn about the elements in these categories in brief. S-block elements. Students, look at this electronic configuration of sodium atom. Here, the last electron is distributed in S subshell. Such an element is called the S-block element. Sodium is an S-block element. In an electronic configuration of an element, if last electron is distributed in S subshell, then the element is an S-block element. All the elements of group 1 and 2 are S-block elements. P-block elements. Students, look at this electronic configuration of oxygen atom. Here, the last electron is distributed in P subshell. Such an element is called P-block element. oxygen is a p block element. In an electronic configuration of an element, if the last electron is distributed in p subshell, then the element is called a p block element. All the elements of group 13, 14, 15, 16, 17 and 0 are p block elements. D block elements. Students, look at this electronic configuration of iron. The energy level of 4s is less than that of 3d. So electrons are first distributed in the 4s subshells, and only then the electrons are distributed in 3d subshells. Thus, the last electron is distributed in d subshell. Such an element is called d block element. Iron is a d block element. In an electronic configuration of an element, if the last electron is distributed in d subshell, then the element is called a d block element. All the elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 are d block elements. The d block elements are also known as transitional elements. F block elements. In the electronic configuration of elements based on subshells, the last electron may get distributed in F subshell. If the last electron is distributed in F subshell, then the element is an F block element. In the elements of lanthanides and actinides, the last electron is distributed in F subshell. So, all the elements under the lanthanides and actinides are F block elements. F block elements are also known as the inner transitional elements.